Okay, so now we're going to do, what did we just do? We just did 59. We're going to do number 60. 60. Polar. We love a polar coordinate. So we are going to let the region that lies in between the polar curve inside r equals 1 minus sine theta inside, and then outside of r equals 1. So sketching, these can be annoying, but I have come to realize if you just plug in points, which is what I tell everybody if they don't know how things look, that does get us our answer. So I will say it is important to just know that the equation of the line r equals 1 is just going to be a circle with radius 1. So if there's anything to know, that's the one thing to know. All right. But for this, we could just plug in some points. All right. We can go around the circle. I thought it was good for me to do 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and then 3 pi over 2. And honestly, that should be enough there. So if we do sine of 0, that's 0, and then 1 minus that, so that'd be 1. If we do pi over 4, sine is root 2 over 2, so this would actually be 1 minus root 2 over 2. And that is going to be, I just denoted this as like less than 1 just for graphing purposes, because I know that you probably won't have access to a calculator. And then pi over 2 is going to be 0, and then 1, or excuse me, pi over 2 is going to be 1, but 1 minus 1 is going to be 0. And then 3 pi over 4 is actually going to be the same answer as pi over 4. That's going to be less than 1. And then at pi, we have our same answer because our sign is going to be 0. 1 minus 0 is 1. And then the only thing that's different is now 5 pi over 4, that equals negative root 2 over 2. So this is actually going to be 1 minus negative root 2 over 2, or 1 plus root 2 over 2. So this is going to be greater than 1. And then 3 pi over 4, that is going to be negative 1. So that would be 1 minus negative 1, which would be 2. So this kind of helps us understand our graph. So at 0, we are at, kind of weird to graph these. At angle 0, because again, our angle is going around in a circle. So at 0, our radius is 1. And then at pi over 4, so at this angle, shooting up like this, we're actually going to be less than 1. So that's why I kind of just did right in there, right in between. And then at pi over 2, we're going back to 0. And then at 3 pi over 4, so at this angle, we are going to be less than 1. And then at pi, we are going to be at 1 again. So when we're over here, on this side of it, we're going to be at 1. So if we actually go from 0 to pi over 4 to pi over 2 to pi over 4, or 3 pi over 4 to 0. So that is kind of how we end up getting like 2 humps, basically. And then if we go down, so now 5 pi over 4 is going to be in this direction. This is actually going to be greater than 1. So at 5 pi over 4 is actually going to kind of be around here. All right. And then at 3 pi over 2, we're going to be at 2, which is going to be 1, 2. Again, this is our radius. We're not x and y positive, negative. At this point in our angle, we're 2 away from the center. And then I didn't continue it, but you would get the same answer for 7 pi over 4, which would be this angle. And then we're greater than 1, that angle. And then if we go to 2 pi, we get 1 again. So as we go from pi to 5 pi over 4 to 3 pi over 2 to 7 pi over 4 to 0, should be a little more curved than what I ended up making it, kind of like this, I would say. Yeah, that's what she ends up kind of looking like. So that's how you would figure it out. Do some practice, plug in some points, and you'll get the right answer. It's just as you work your way around the circle, how far away are you from the center? Those are our coordinates. And we want to be inside this funky one. So we're going to be in this, kind of looks like a heart a little bit. And then outside of r equals 1. So we're going to be outside of this guy. So this is actually going to be our area that we want to find. All right. And it's kind of nice because we do kind of know what those boundaries are, because we did the work of plugging these in. So at 0 and at pi, we're at 1, and our r is always going to equal 1. So these equal, so this is going to be 0, 1. Again, that is our theta and our r. And then this is at pi, 1. So that is what those 2 points meet at, which is nice. So we don't have to actually worry about that later. Okay, so now I need to find that area. Our area function or formula going to be with our 2 bounds. And then our formula that we just used is going to be 1/2 r squared d theta. So whatever our r ends up being is going to end up being squared regardless of this guy. And whenever we do, if we were just doing this circle, it would just be 1 squared. Easy peasy. Same with our regular integration and area formulas. But whenever we have 2 boundaries, we are going to need to do a subtraction. So I'm going to need to do inside of this guy, and then I'm going to need to subtract this guy. So I'm going to need to do this outside for 1, our outside radius, minus our inside radius. I know we're kind of, I'm going to erase these, because now we need to think about it as what radius is on the outside and then subtract what radius is on the inside, because now these basically flopped. Now my outside radius is going to be this guy and my inside radius is going to be this guy. But I will pull that 1/2 out because I don't want to deal with that. And our bounds, since we're under this, I'm actually going to update my bounds. Because we're not from 0 to 1, we're actually from, or excuse me, 0 to pi. We're from pi to 2 pi because we're underneath our circle. So our bounds are actually going to be from pi to 2 pi. All right. And then our outside radius is going to be 1 minus r, or excuse me, 1 minus sine theta squared minus 1 squared d theta. And that is what that ends up being. I will go through this just because I need to go and I apologize, but I'm going to go through this one, and then all of the other problems are very similar to this because they just give you the bounds, and it's actually the same trig identity that they're doing each time, but she has errors in her answer key. For this problem, 60, 62, and 64. So I will send you those and how I did them. 64, I think I did slightly different than what she did. I'll do 64. But I gotta skip over 61 and 62 and 63. I'll send you pictures for them. All right. So let me mark that down. 61, 62, and 63. So this guy, all we need to do is square. So this will be 1 minus 2 sine theta minus or plus sine squared theta minus 1, which is nice because those actually end up canceling. And then it is the identities. I'm going to put these up here. Sine squared theta equals 1/2. Yes. 1/2 1 minus cosine theta? No. 2. Cosine 2 theta. That's our trig identity. And then we're also going to do the same thing later on for cosine. And that equals 1/2 1 plus cosine 2 theta. So these are going to be used in every single one of these problems. Not correctly in the answer key, but in mine they are. And check with ChatGPT because that was helping me scan for errors too. So here I'm going to do 1/2 times the integral of -2 sine theta times or plus 1/2 times. This is going to be 1 minus cosine 2 theta d theta. If I distribute my 1/2, I get 1/2 minus 1/2 Yep. And then here I can integrate. So this will be 1/2 times the integral of sine is, or negative, yeah, the integral of sine is negative cosine. So this actually turns into a positive 2 cosine theta plus 1/2 theta minus, and then this is where we would need to use our chain rule, or excuse me, our U substitution, basically. I almost think of it as chain rule because it basically is. It's like inverse chain rule. But we would end up dividing by whatever this derivative is. So it's actually going to be divided by 2. I already have a 1/2 here. 1/2 divided by 2 is 1/4. So this would be minus 1/4 cosine, or not cosine, sine. What are my bounds? Pi to 2 pi. Yep. So we just plug in everything, right? So we get, my eyes keep going down further. 2 pi cosine's 1. So this is going to be 2 times 1 plus 1/2 times 2 pi is just going to be pi. And then that is going to be plug in sine of 2 pi or 4 pi, and that actually equals 0. So we actually don't really need to even worry about that portion of this guy, which is nice. And I think that might be where an error is. There's an error somewhere. I think it's a typo. I think she actually gets the right answer, but a step is like mistyped, basically. I think that was what it was. And then this is going to be minus 2 times negative 1 plus pi over 2. And with algebra, you get 2 plus pi over 4, which I believe is what she has. Yes. So, not a crazy. And this, because these, in these problems, these just keep coming up. So that is why these two identities get used, I think, in every single one. So that is number 60. And I think that was all it was. Yep, no A, B. Love that. And then I'll do 64. And I'll send you pictures for 61, 62, and 63. This one's a little weird. She solves it differently. 64. She just has an extra 1/2 floating around. Am I still recording? Yes. So if you notice in number 64 in the answer key, she has 1/2 times 2 sine, ... And then the 1/2 and the 2, she just removes the 2 and keeps the 1/2 floating around. So I got 1/2, ChatGPT got 1/2, and her error's like pretty obviously right there. So it's just something that just lingered on. I will say in number 62, she messed up like twice. So she got the complete wrong answer in number 62. So that's why I'll send you those solutions. Okay. So we just want to find r squared equals 2 sine theta cosine theta from the interval 0 to pi over 2. That's what we want to be able to find. So my radius is actually going to be, I really wrote out these steps and you didn't need to, because our area formula equals our two bounds times 1/2 and then just r squared. And we're just given r squared. So this is actually just going to be 2 sine theta cosine theta. We actually don't need to take the square root and then square it because that basically is an inverse transaction. So we don't need to do that. We're given r squared. So we just need to plug that simply into the formula and not worry about it. So this is 1/2 times 2. So I can actually remove those. And I just have this function. I don't know if you remember this function, but this one is a tricky one. She solves it with an identity. How does she do it? I did it differently. So because I tutored somebody in this problem recently, so I remembered, well, first we did integration by parts earlier, so I was I can do integration by parts. I can do this, I can do this, something's going to cancel. So that's what I did. So I said u dv, so this is my u, and my dv is cosine theta d theta. So my derivative of u is going to just be cosine. And then my integral is going to be sine. Love that. So all I need is going to I'm going to write this in a specific way. So my integral from 0 to pi over 2 of sine theta cosine theta d theta equals uv, so this would be sine squared because it's sine times sine, theta, minus the integral of v du, sine theta cosine theta d theta. I like this process because there's no trig identities that you need to remember, and that's why I like it. If you noticed, we are exactly where we were. Nothing changed, right? That might be disheartening, but it's actually the solution to this problem. Because if we notice, our bounds are the same. They wouldn't change. This and this are on the opposite sides of the equation. They're the same exact thing. So I can basically treat them like an x. This is basically like I have x equals sine squared theta minus x. Because they're the exact same thing. It's going to be a number. So what I can do, if I wanted to solve for x, wouldn't I add x to both sides? And I would get 2x equals sine squared theta. And then to solve for x, wouldn't I divide by 2? So x equals sine squared theta divided by 2. That's how I would do it if it was an x. So that's what I'm going to do, even though it's a scary looking integral. I have this equals this minus this. I can add an integral and add the same integral. And then I get 2 integrals. And I'm just not labeling my bounds because I'm just not. Equals sine squared theta. And then all I needed to do is divide by 2. Those cancel. So my integral equals this. Such a trick. I forgot about it. But it exists, and it works, and it's valid. So my integral is actually this. So now I can just evaluate at my bounds from pi over 2, or from 0 to pi over 2. So sine of pi over 2 is going to be 1. And that's going to be divided by 2, because we have sine squared over 2. And then minus 0. If I plug in 0, sine of 0 is 0. So I actually get 1/2. She gets 1 over 4, but again, that is, if you look at her work, you can see she has 2 times 1/2. I erased it earlier, and she just kept the 1/2 and erased the 2. So that's a very easy thing, which makes sense why she got 1/4, because she just had an extra 1/2 floating around, and 1/2 times 1/2 is 1/4. So, that is how long have I been? I'll send you. Yes. But anyway, so yes. Let me know if you have any questions. If you want to go through any of the ones that I skipped, please let me know, and I can do this, I think tomorrow. I'm just grading. And it was only a handful of problems just to make it a little bit less. But yeah, so hopefully this helps. Good luck studying. And if I don't actually speak to you, it was great working with you and tutoring you. So yeah, good luck. And maybe I'll chat with you later.